In this video, we are going to show you how we can model a real-life problem using y equals a sine k bracket theta minus p bracket plus q if it's a sinusoidal periodic situation. Or we could use a cosine y equals a cosine k bracket theta minus p bracket plus q. The value of the AKPQ could be found from the given information, either from the graph or from given information, maximum, minimum, period, those informations. So for amplitude, we know that is over height divided by 2, so it's maximum minus minimum divided by 2. And the period is, the k value is in 360s, how many cycles in one whole 360. So one period will be the 360 divided by k. And if the period given, then we could find the k by using 360 divided by period. And in our homework on deltamath.com, they are using irradiance. So we are going to use 2 pi equals 360, and so the k value will be 2 pi over period. So this is different from the degrees. So pi is corresponding to 180 degrees. And horizontal translation is p, vertical translation is q. The axis of the curve, or the midline of the curve, is y equals q value. It's middle of the maximum minimum, so it's maximum plus minimum divided by 2. For the y equals sine x, this is parent function. And for the transformation, the new point, if the PQ is here, then the new graph will be this way, if it's just for transformation. So that the PQ is the starting point, how it is translated. The equivalent expressions is a sine k bracket x minus p plus q. You could connect it with a cosine. It's just minus 90 degrees horizontal translation. 90 degrees difference between these two angles, it will give the same graph. So the steps for modeling a sinusoidal function is determine the maximum minimum first, and also find from the maximum minimum you are able to find the a value is maximum minus minimum divided by 2, and the q value is the middle of the line is maximum plus minimum divided by 2. So by determining the maximum minimum, after that you are able to find a and q. And from the graph or given information to find the period, then we could find the k value is 360 divided by period, or pi divided by period for the unit in radians. The difficult part is the horizontal translation p value. And for the sine, we know that it's a starting point, so we find the midpoint on the increasing interval for y equals sine. And for cosine, the cosine is starting from the maximum, so you are going to find the starting point on the maximum of the graph, that x coordinate, the x coordinate of the starting point of the y equals cosine or y equals sine, it will give you the p value. So the starting point is your p comma q. on the graph. So after we have the A, K, P, Q, then we sub into this general form A, K, P, Q, A, K, P, Q. Then you will have the equation for the sinusoidal function. So now we are going to see if a graph given, how we are able to following these 4 steps to find the equation of this graph. So from here we are going to find the maximum, minimum first. So maximum from the graph is highest point of the graph is 8. The minimum is the lowest point of the graph is 4. And after that, we are able to find the p-value and the q-value. A value and q-value. The p-value, we are going to read it from the graph. So A value is overall height divided by 2. So it's from the middle, then up to the maximum, down to the minimum, that is your A value. So it's overall height divided by 2. So maximum minus minimum divided by 2 give you 2. Then the middle of the graph is your Q value. So it's maximum plus minimum. So A value is subtraction, the difference, and the Q value is the middle is plus, is average. So 8 plus 2 divided by 8 plus 4 divided by 2 give you 6. So we have A and Q. Now we want to find the period. Then from period we are able to find the Q value. So period is we find either from the lowest point to lowest point or from the maximum to maximum or minimum to minimum or the middle to the increasing middle to the increasing middle. So this one is 180 degrees. So period is 180, then the K value is in 360 how many cycles? So 360 divided by 180, you will see in 360 you have 2 cycles. So K is 2. So you have A, P, A, Q, and K. The P value is the starting point for the y equals sine x. The starting point for the sine is the middle on the increasing part. So this is a starting point. We have 45 and the middle is 6. This is P, this is Q. So P is 45. The x-coordinate of the starting point of your sine wave. So sine wave starting point is the middle midpoint on the increasing interval. So now we have the AKPQ. We are able to write sub in the A is 2, then K is 2, P is 45, then plus a Q. That is equation. So general equation is A sine K bracket x minus P bracket plus Q. So we just sub in the A, K, P, Q, and this is a equation of the to describe the given graph. So this is how we are able to determine the equation for this model. So we are going to continue practice this one. The graph not given, but the descriptions for this function is given. So has an amplitude of 2, period of 180, and maximum at 0.3. So represent the function with an equation in 2 different ways. So the easier way is we could sketch it. So maximum is 0, 3. So this is 0, 3 is a maximum point. Then period is 180. It means after 180, you will repeat this point. And this is maximum. The amplitude is 2, so it means from 3 down 2. It will give you the midpoint. And from here down to again, -1, it will give you the minimum. The minimum will be at middle of the two maximum. So it's 90, -1. Then quarter points is 45 at middle, 45 at middle. So if we graph it, it will be this way. So the reason why we could graph it this way, because we have a circle, so the maximum is 0, 3, then after quarter, it will go back to the middle. So if this is 3, then quarter graph again is -1, then quarter graph will be 1, quarter graph will be 3. So that's reason from this 0, 3, then rotate 180, it will go back to 3. Then after that, quarter point, the half of the period, it will give you the -1. The quarter point will be the middle. So this is how you graph this one. And once we have the sketch, or without the sketch, we could find out that A is given is 2, period from the given information is 180. So from period, we are able to find the K value. So 360 degrees, one cycle is 180, so you will have 2 cycles in 360. Then after that, we are going to find the midpoint, that is your Q value. So from maximum to the middle will be 3. Maximum minus A value give you the middle. Maximum, take away the A, then we have 3 minus 2, that is a midline. So A, K, Q, then the P value. P value is x coordinate of the starting point. For y equals sine x, the starting point is the middle of the increasing. This is a starting point. Middle of the increasing interval. So from here, increasing midline is this point. And this point, if we read it, it will give you 135 and 1. So P value is x coordinate. So for y equals sine x, the P value is 135. The transformation will be from the original, right, 135 up 1. If for y equals cosine x, so if we graph cosine x, it will be the maximum first. So we are looking for the maximum point, the x coordinate. So from the graph, you are going to see it is a P value equals 0. So the x coordinate is 0. So for y equals sine x, y equals cosine x, the P value will be different. Then we are going to sub A equals 2, K equals 2, P equals 135, and Q equals 1 into y equals sine, the general form, into y equals A sine AKPQ. sine k bracket x minus p bracket plus q. Then we have y equals 2 sine 2 bracket x minus 135, then plus 1. This is a one form for y equals sine x. And for y equals cosine x, the a, k, q same, but p is different. So sub a equals 2, k equals 2, but now p is 0. It's a maximum start. Q equals 1 into y equals cosine. A cosine k bracket x minus p bracket plus q. This is general form for sinusoidal function. So y equals 2 times cosine 2 bracket x minus 0 bracket plus 1. Then this is done. So from here you will see A is amplitude, period is the k value 360 divided by period, and if it's a readings, it will be pi divided by the period. It's 2 pi divided by period. That is in readings. And how you are able to remember the 2 pi is just think the circumference. Circumference equals 2 pi times r. And the circumference equals the angles times r. So it's just the angle is for the whole circle is 360, then times r. So that's the reason 2 pi is equal to 360. So this arc length equals theta times r. So the angle times radius give you the arc length. For whole circle is 360 times r. It also equals 2 pi times r. So degrees and pi is 360 equals 2 pi. So that is for the modeling of the sinusoidal functions. And the next one, we are going to practice on a word problem. So we have the rider on a Ferris wheel could be modeled by 20 times sine 3t minus 90 plus 22. The h at t is not h times t, it's a function notation. It represents that t is input. T is input and h is function's name. H at t is h is height in meters and t is a time in seconds. So determine a, k, p, q, then graph the h at t from one period in the grid given. So this one, compare it with a sine k bracket x minus p bracket plus q. This is general form. Compare it with this to get a value is 20, k value is 3, and the p value, be careful, we need to factor the 3t minus 90 first. So we take the k value 3 out, then each term divide by 3 give you 30. So then the p value is 30. Opposite with minus, so it's 30. And q value is a number outside of the whole function, that is 22. So after we determine it, then we are going to graph it. We are going to use a shortcut to graph it. So that shortcut is step 1, we find the starting point, PQ. So the PQ is 30 and 22. Then step 2, we are going to use a period to find the P plus the period, then Q. So for this one, the period is 360 divided by 3. So period T equals 360 divided by 3 give you 120. So it means from this point after 120 it will repeat. So 30 plus 120 give you 150 and 22. So this is a whole period point. And step 3, we are going to find the middle of these 2 points. If this is a sine, then we know the sine is first point, last point. The midpoint will be same as this first and last point. So that is a first point. This is point 1. This is last point. We call it point 5. And this one will be point 2, 3, 4. So point 3 will be the middle of these two. So middle of these two is 30 plus 150. Then divide by 2, then y value don't change. So that it will give you 90, 22. And step 4, this is a point 3. We are going to find the point 2. Point 2 will be from the middle up A. So will be quarter points. So P plus quarter of the period. Then the Q value, y value will be Q plus A. Now you are going to, this A is not amplitude. This A is A value at front of the function. So we are going to have middle of this quarter of this one will be 30. So 30 plus 30, this is 30, 90, 150. Then 30, 90 middle give you 60. Then Q plus A value is 20. Okay. And step 5. We have one more point to find, the lowest point, point 4. That is middle of 90 and 150. So it's middle of 150 and 90. It will be Q value, take away A value. So you will have 120 and 2. So now you have 5 points. So we are going to see the lowest point is 2. So we are going to put the x-axis here. Nothing below 0. So this is time t and this is height h. H at t in meters, this one in seconds. So we have this 5 points and the maximum is 150, so we could go by 30, 60, 90, 120 and 150. And the lowest point is 2, maximum point is 42, so 1, 2, 3, 4, 5, 6, 7, 8. We may go by 5. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45. Then first point is 30, 22. So 30, 22 will be here. Last point is same, add 120 on the same one. Then middle of these two is 90, 22. And the middle of 30 and 60 is A value is 20, so add 20. And between these two is minus A is 2. So you have these 5 points, connect them, then you will have the graph. So this is y equals 20 sine 3 bracket x minus 30 then plus 22. So 22 is your Q value, that is your middle. So y equals 22, that is your midline, the axis of the curve. So this is a graph, and you could extend it. So 120 is period, so the one period point is minus 20, 120 is give you 0, so 0, 2 is starting point. So continue. You have more than one revolution here. Revolution is also one period. They are same. So now we are going to describe the transformations from y equals sine t to this y equals sine y equals 20 sine 3 bracket those ones. So question B. Describe the transformations. So we are going to use words to describe it. So we are going to say the graph of y equals x sine x, the parent function. A value we know it is changing the y direction, so it's vertically stretched. By the factor of A value, use the positive number. This one we put the A value here. If A is negative, we are going to put reflected in the x-axis, but here there's no reflection. A is positive, so we leave the reflection out. And for the k value is horizontal stretch or compress, so horizontally stretched. By a factor of, now you will see it is, before it's 360, now it's 120, so it's 1 over k, 1 divided by 3. 360 times 1 over 3. And after that, translated, the PQ. Translated, the starting point is right 30 up 22. So it will be right 30 units. And the Q is 2, so 22 and up 22 units. So what we have done is we include the vertical stretch A, horizontal stretch 1 over k, then the P left right, Q up down. And this is done for the describe the transformations. Then after that, from this one, we are going to see the minimum maximum. So maximum, we know it is Q, then plus absolute value of the A. So the Q is 22, then plus 20 give you 42. And the minimum is from middle down amplitude. So minimum equals middle is Q, take away the absolute value of the A, so take away the amplitude. 22 minus 20 give you 2. Then the period, we know that is 360 divided by K. The height after 30 seconds. The height after 30 seconds, it means T equals 30 sub in, so it's 220 times sine 3 brackets 30 minus 30, then plus Q is 22. So it will give you 20 times sine 3 times 0 give you 0 plus 22, then sine 0 give you 0, it is 22. So H at 30 seconds, it is 22, the height. Then after it asks you the time required to complete one revolution, it is the period. So we know the period is 360 divided by K. It is 120. So that is 1 period. And question D, it asks you what the effect on this function if the platform from which the person enters the ride is raised by 1 meter, and if the Ferris wheel turns twice as fast. So we know that from here, it's kind of, we have a circle. So if we graph, we could draw a Ferris wheel here. I will draw it, not perfect Ferris wheel, but maximum minimum height. So this is Ferris wheel. Here is a stand. So this is the axis of the L for the Ferris wheel. So if the platform, this is under point of the platform. So if the platform is raised by 1 meter, so the whole Ferris wheel will be up. So it means the whole graph will be up 1 meter. Then the midline, the amplitude is not going to change, but the midline will change. So Q value will change up by 1. So question D. If the platform up 1 meter, it means your Q value is up by 1 meter. All the others won't change. And if the Ferris wheel turns twice as fast, so turns twice as fast, which one will happen? Will change is the period is from 120 becomes half, is 60 seconds. Then what will change will be the K value. K value is 360 divided by period. So it's 360 divided by 60. So 6 is your K value. So it's in 360 you have 6 cycles. So these are the changes. If the platform up 1 meter is Q value up. If the period shorter, then the K value is bigger. And on the graph, it just means that it's just shorter for the period. In 360, you have 6 periods, so each period is 6 cycles. Each period is 60. So that is all for today's this video, and what we have covered is from the given information. If it's a graph given, then you are going to use the maximum minus minimum to find the divide by 2 to find the amplitude, and the k value is 360 divided by period. The q value is middle of the graph, is maximum plus minimum divided by 2. For the p value, it is depending on the starting point on the graph. So for the sine graph, the starting point is midpoint on the increasing interval. So you look for that on the graph, that y point, the value is p comma q. So you pick the point that is close to the y-axis, because after one period it will repeat, you have another starting point. And for the cosine, it's a maximum as your starting point. So on the graph, if you have the find the maximum point, that point, the xy coordinate is p comma q. So that is all for today's lesson. Thanks for watching.